With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today we are going to discuss one question on mean value theorems. Here in this question we are given two statements. This is the statement 1 and this is the statement 2. And we are also given the four options. And these four options are regarding these two statements. Now after reading these two statements we need to choose one among these four options. So let us first consider on the statement 2. Here in statement 2 they have given that between any two roots of an equation f of x is equal to 0, there is a root of its own derivative, that is f dash x is equal to 0. So here this statement 2 is completely correct. Why? Because this is a result of the mean value theorems, and we can also see that by using a graph. So let us see this by using a graph. So here we have a graph like this. This is a graph, and suppose this function f of x is equal to 0. The function f of x is equals to 0 has two roots, let's say alpha and beta. These are two distinct real roots. So if we draw the curve of this function, then the functional value of this function f at alpha and beta would be 0. So if let us say that this is the point alpha and this is the point beta, and if we draw a function like this, then this is the function, let us say f of x is equals to 0. So here in this figure we can see that this function f of x is equal to 0 has two roots, that is alpha and beta, and in between these two roots f dash x will always become 0 at least one time, just like it is becoming 0 here. Here the tangent of this function is becoming 0 like this. So this will always be going to happen at least once, that f dash x becomes 0 in between the values alpha and beta. So f dash x is equal to 0. The derivative becomes 0 if this function f of x has two roots, two real distinct roots. So we have seen this graphically, and this is also a result of the theorem. So this statement 2 is completely correct. Now let us focus on the statement 1. So in statement 1 they have given that the equation e to the power x minus 1 plus x minus 2 is equals to 0 has only one real root. So what we are given? We are given this function e to the power x minus 1. We are given the function f of x as e to the power x minus 1 plus x minus 2 is equals to 0. This is the function f of x is equal to 0. Now by using hit and trial method we can easily conclude that the functional value of this function x at x is equals to 1. At x is equals to 1 we can see that the functional value 1 will be 0. So we can say that x is equals to 1 is a root. It is a root of f of x is equals to 0. So now we have got one root of this equation. Now let us find f dash x. So if we get the value of f dash x, then we get e to the power x minus 1 plus 1. This is the value of f dash x. Now if we see that e to the power x minus 1 will always be greater than 0, and this one will always be greater than 0. So we add two things which are greater than 0. So this f dash x, we can conclude from this that f dash x will always be greater than 0. So we have seen that we have concluded that this function f of x is always increasing, because its derivative is always greater than 0 for all values of x belonging to R. So now if we draw the graph of this function, let us say this is the x-axis and let us say this is the y-axis, and if we draw the graph of this function, then since it is always a increasing function, so it will always going to increase like this. This is the function f of x is equals to 0, and we have got only one root of this function, that is x is equals to 1. So that root is 1. So this function f of x does not have two roots. The function f of x has exactly one root. And that root is 1. So here this statement 1 also becomes true, that this function, this expression is equal to 0 has only one real root, which we have proved just below. Now statement 1 is true and statement 2 is also true. Also here we can see that statement 2 is the correct explanation of statement 1. Why? Because in statement 2 they have written that if there is a function f of x is equal to 0 and if it has two roots, then its derivative f dash x is equal to 0 must have at least one root between those two roots. So we can apply this statement 2 to get the result of statement 1. Here in statement 1 we only got one root, there are no two roots. So we can simply say that this equation will not be having f dash x is equal to 0 because it has only one root. So our correct option is statement 1 is true, statement 2 is also true, and statement 2 is the correct explanation of statement 1. So the correct answer is option 1. This is our solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.